Okay, these are solving systems of equation word problems. So these usually involve having x and y and two equations, and you kind of have to find the coordinate of intersection in a word problem. All right, so the first problem is, let's see, Maya is using ribbon to create girls' hair barrettes for a craft fair in Fairfax. She made 11 small barrettes and 14 large barrettes using a total of 167 yards of ribbon. Then, for another craft fair in Kingwood, she made 10 small barrettes and 15 large barrettes for a total of 170 yards. All right, so that's the first situation up there. Then the other one is 10 small ones and 15 large ones for 170. And the key is in the question. So it says, how many yards of ribbon does Maya use for each? Okay, so we need to define a couple of variables. So you can say x equals yards of ribbon for small barrettes, because I said so. Could have made it y. Small barrettes. And then y equals yards of ribbon for large barrettes. So the idea is that the small ones, whether she's selling them at the craft fair in Fairfax or if she's selling them in Kingwood, the small barrettes use the same amount of ribbon and the large barrettes use the same amount of ribbon. Okay, so go back to the first situation for Fairfax. Fairfax situation. We have 11 small barrettes, so 11 times the yards, that is yards of ribbon that are used to make the small barrettes, plus this 14 number right here, times the yards used to make the large barrettes. So 11, let's see, there's 11 small barrettes times the yards for small barrettes plus 14 small barrettes times the yards for small barrettes gives you the grand total yards of ribbon or length of ribbon, which is 167. All right, so for the other situation, which is Kingwood, right, you have that's the exact same color as the one above. All right, so for Kingwood, it is 10 small barrettes and times however long those small barrettes are, plus 15 small barrettes times however long those barrettes are, equals a ground length of 170. Okay, so we're going to do a system of equations, which means we can solve with elimination or substitution. But for this one, it seems like elimination would be better. So we're going to stack them up like this. Okay, and ideally, this would have been like a 10, and that would have been 10, and maybe ideally this would be like negative 10, and you could just wipe them out. But that's not the situation. We have that instead. So what you want to do is you want to multiply the top by negative 10. All right, so we multiply the top by, let's see, negative 10. I'll make that negative. And the bottom, by 11. And the reason why you want to do that, so basically I multiply them by each other. It's kind of like when you're doing fractions. Let's say you want to add like 1/10 plus 1/11. you're going to want to make a common denominator, right? So you want to multiply the top and bottom here by the other side, and this one by the other one over there. That way both denominators are the same. So that's what we're doing over here. So, yeah. So we want to get 110x, or on the top, negative 110x, and on the bottom, positive 110x. All right, so let's do that. So we multiply across like this, just distribute. All right, so 10 times 11 is, or negative 10 times 11 is negative 110. And negative 10 times 14 is negative 140. And negative 10 times 167 is 1670. It's negative 1670. And multiply 11, same idea. You got to distribute that 11 to everything down below. Okay, so when we do that, we're going to get 11 times 10, which is positive 110. And then 11 times 15, 11 times 15, 165, and that's positive, so 165y, and 11 times 170, which is 1870. Okay, now we're ready to eliminate. All right, so we're going to go ahead and add straight down, and this side gives a 0, which is what we want. So we need to wipe out, bam, and then we're going to do 165 minus 140. All right, so 165 minus 140 is 25. Wait, my y vanished. There should have been a y there. Whoa. There's a y right there, because there's a y right there. Okay. Totally going to fix that in the edits. All right, so there's 165 minus 140, which is 25. 25y. Then we're going to do 1870 minus 1670, which is 200. Okay. So now we'll divide. Oh, you got a sneak peek at the next problem. Okay, so now we're going to divide by 25. And we have y equals 8. Okay, so what does that mean? Go back over here. Y is yards ribbon for large barrettes. Okay, so we have y is 8. I guess I'll put that up here. Got half our answer. And to find out x, the yards of ribbon, the length of ribbon for the small barrettes, plug in this y for x in one of the two originals. So you can go ahead and put it, let's see, you can go ahead and put it for in here, or you can go ahead and put it in here. It doesn't matter. And the reason why it doesn't matter is because they have that y value, that length of ribbon is the same in either situation. It's going to be consistent. So let's plug it in. I'll choose this one. So go right there, plug it in right there. You don't have to plug it into this one here. Just plug it into the earlier one. So now you have 10x plus 15 times our plugged in value of 8 equals 170. All right, so you have 10x plus 15 times 8. Quick mental math. 120 equals 170. All right, minus 120, minus 120. 10x equals, that doesn't look like 120. One sec. Equals, right, that's minus 120. It's a little better. All right, so 50. Yeah, 10x is 50. All right, divide by 10, divide by 10, and we have x equals 5. All right, so these are our two values, and you just have to make sure you answer them correctly when you answer the question correctly. So we have here, x is 5. So yeah, so there's 5 yards of ribbon for the small barrettes and 8 yards of ribbon for the large barrettes. Okay, next question. This one here. All right, so this one's very similar. We're only going to do one similar. Okay, the drama club is selling a gift basket to raise money for new costumes. During the fall play, they sold a combined 22 regular gift baskets and 5 deluxe gift baskets. That's during the fall play. Earning a total of $716. All right. During the spring musical, they sold 25 regular gift baskets. And like that, technically those are two different colors, but you know, I'll put green. 25 regular gift baskets and 3 deluxe gift baskets for a total of 701. Okay, how much are they charging for the different sized gift baskets? So we're assuming that they're charging the same amount in the fall at the same rates for the fall and for the spring. So let's look at the question so we can set our variables up. They're asking how much do they charge for the different size gift baskets. So I'll say X equals price of regular baskets and Y equals price of the other guys, of the deluxe baskets. Okay, so now we have that. Now we set up our equations. So let's just read the problem again. But I do know the total, if it says total, so like over here it says a total of 716, and the other one says a total of 701. I know those numbers are going over here. First one is total of 716. All right, so the other one says total of 701. All right, so we have 22 baskets, 22 regular baskets. All right, so 22 at a price of X dollars per basket plus 5 deluxe baskets at a price of Y dollars per basket is equal to that number way over there. Then over here, for the second situation, for the spring musical, they have 25 regular baskets at a price of X dollars per basket plus 3 deluxe baskets at a price of Y dollars per baskets because it's the same price for both seasons, and the total they earned was 701. All right. Okay, so I stacked them up. So I'm choosing elimination for this problem instead of substitution. And I don't know if that's any easier, but let's do it. So we get to choose. Do we want to wipe these guys out, or do we want to wipe these guys out? Well, I'd rather have like common terms or denominators or whatever with these two than have to deal with these two. I'd rather multiply this by -3 and this by +5 versus multiplying the top by -25 and the bottom by 22. Okay, then we distribute. So we have to multiply the entire equation by your new value. So we have 3 times 22, which is, or -3 times 22, which is -66x minus 15y equals 716 times 3. Quick mental math again. You don't hear that in the background. 2148. And negative times negative is negative, negative times positive is negative, negative times positive is a negative. And on the bottom, 5 times 25 is 125. And then 5 times 3 is 15, so we have 15y. Don't forget that y. And then there's 5 times 701, which is 3,505. Long pause. Okay, now we're going to go ahead and add straight down. So just add right here. So negative 66 plus 125, or 125 minus 66, and you're going to get 59. So we have 59x, and then we have our elimination right here. Bam. We can do better than that. Hold on. I'm thinking green. Yeah, there we go. And then we have equals 3505 minus 2148. And we get 1357. Okay, so divide both sides by 59. Right, so divided by 59, gone, divided by 59. And we find x to equal 23. And so it's good to get a whole number. Okay, now we get to plug our 23. By the way, 23, what does that mean? X equals 23. We know that that's the price of the regular baskets. Now we're going to find the price of the expensive ones. So let's go ahead and put that in for X in either one of our two originals. I choose this value right there. Okay, so let's do that off to the side over here. So we're going to plug in X for our 20 in our 22 right here, or it's just going to go right there. All right, so you're going to go 22 times X plus 5y equals negative 716. Okay, and I like how I didn't actually plug that in. Hold on. That's just me copying the problem down again. So you have 22 times 23. There, plugged in. All right, so 22 times 23 is 506. Okay, so 506 plus 5y equals negative 716. All right, minus 506 minus 506. This is the part of the problem where I realized that this looks like a negative, but it's not. It's part of the equal sign right there. See that? That's an equal sign. It was never negative. So this is positive, okay? Positive, positive. Okay, all right, so we add straight down. So we have 0 eliminated on the left. Then we have right there. Then we have 5y equals 716 minus 506. 716 minus 506, which is 210. Okay, divided by 5, divided by 5. And we get y is equal to 42. That means these deluxe ones, really only the one, these are the baskets that the grandparents buy. So y equals 42. That's the price of the deluxe ones, 23, price of the regular ones. And that's it. Okay, next problem. Aunt Lila is pricing cakes for a baby shower she's throwing. She wants one large cake shaped like a duckling and also some cupcakes in pastel colors. Winchester Bakery charges $2 for each cupcake. All right, so this first place charges $2 for each cupcake plus $38 for the large cake. And Kelsey's Sweet Shop charges $26 for the large cake and $4 for each cupcake. If Aunt Lila orders a certain number of cupcakes, the cost will be the same. So let's think about this for a second. We have the first situation where it's $2, right? It's $2 for each cupcake. Wait, why am I doing it in that color? Hold on. So you have $2 per cupcake, and then it's $38 for the large cake. The other scenario is 26, where is it? Oh, $4. Did you see that right? Yeah. It's $4 for each cupcake, so $4 per cupcake, and $26 for the large cake. And I don't know what I'm trying to spell. And if Aunt Lila, you know, it's kind of on the cheap side, and she just wants to have one cupcake, one little one, and one large one, the best deal would be this one, right? Because it's 26 plus 4, just one cupcake, it'd be $30 versus 38 plus the one cupcake fee of $2 if it's just one cupcake. Then it's $40 versus $30. That's the way to go. Bam. But the more cupcakes she orders, this one will start becoming, this one will be more inviting because it'll start going down for the overall price. Eventually they're going to break even, and then eventually this deal will be cheaper because the cupcake price, the per cupcake price is half the other per cupcake price. All right, but we want to find out at what point, they're asking here, what will the total cost be? Is asking here. If Aunt Lila orders a certain number of cupcakes, the cost will be the same at either bakery. What will the total cost be? And how many cupcakes would that include? So we want to know the total cost where both locations would cost the same. All right, so we have look at the question to see what we want to set our variables to. So we know we want total cost and how many cupcakes. Okay, so I'll say that y equals total cost. And I kind of set it as y because usually y is your dependent variable. So y is a result of x. So the cost depends on the price, the number of cupcakes. So x is a number of cupcakes. Okay, so for let's see, the first situation, we know that the cost, which is y, is going to be the result of, let's see, $2 per cupcake times X number of cupcakes plus that one flat rate of the big thing, whatever that was, the large, $38 a large cupcake. All right. Second situation, the total cost, Y, is going to be $4 per cupcake. So there's the $4 times X number of cupcakes, which is the same as that X number of cupcakes because we want both values to be the same, plus the $26 for a large cupcake. So when you have them like this, these two equations, see these two equations? If you have them like that, and they're in terms of y equals versus the previous problems that we did, where you kind of have like something x plus something y equals something. All right, when they're in y equals format, it's actually easier if you substitute. So I think it is, at least. So all you have to do is just go ahead and put this right here represents y, because it says y equals that. And this right here is also y. And because these two y's are the same, because we're trying to find at what price it's the same. So at lower basic, at what number of cupcakes, the price is the same. So we know the cost is going to be the same. So we know that the y value in the top needs to be the same as the y value in the bottom. Therefore, these guys are the same, which means I can swap the top value for the variable on the left and the bottom. So I can combine them to get 2x plus 38. So I literally just swap that for that. Equals 4x plus 26. Okay, now I have everything in terms of x. So now I can just solve for x. So let's see. I'll do minus 2x minus 2x. Not sure why there's a line there. Minus 2x. All right, and that's gone right here. Then you have 38 equals 2x plus 26 minus 26 gone, minus 26. Okay, and then we have 8 minus 6 is 2. So we have 12 equals 2x. All right, so then divide by 2, x equals 6. So x equals 6. So what did we just solve? What did we define x as? Let's go back to the top. All right, so x is the total number of cupcakes. Okay, so 6 cupcakes. And to find out what that cost is going to be, just plug that back into one of your two originals. So just plug that, just pick one. I choose that one. All right, so then you have y equals 2 times our 6. Plug it right in. Up here, plus 38. Okay, so y equals 12 plus 38, which is 50. So y equals 50. So our answer for this problem, well, I guess $50, is, I'll put it up here. So it's $50 at 6 cupcakes. So I don't know if I put a dollar sign there. For 6. Okay, so if Aunt Lila only buys 6 cupcakes, it doesn't really matter which place she goes to because it's going to cost her $50 either way. And that is it.